Hey everybody, I'm going to try and walk us through the Regents exam questions and break them down. I'm not going to read the flame test. You can read. It says explain why the electron configuration of 2711 represents a sodium atom in an excited state. So it's a sodium atom because there is 9, 10, 11. 11 electrons equals sodium. Right? But that 7 should be an 8. Or that 1 should be an 8. Any of those answers will do. This is only a precursor. The 11 electrons equals Na. That's how I know it represents a sodium atom. That's the least piece. I need you to say something about 7 electrons should be an 8, or the 1 electron, or there should be 8 in the third energy level. Before there are any in the fourth. Okay. So you can talk about the 7, how there should be 8. There should be 8 electrons in the second energy level before there's any electrons in the third, or there should be 8 electrons in the third energy level before there's any in the fourth. Either way, okay? Now, unfortunately, I need to erase that so I have enough room here. Remember, you would actually have the answer booklet to write these in, so you'd have a lot more room to write. Okay, so I'm going to go ahead and erase. So I got room to write my next one here. To explain in terms of electrons how strontium salt emits colored light. So electrons absorb energy. Basically this question is about excited electrons. As soon as you see emits light, you need to be able to say, and actually I don't need to write this all down, right? You guys can just listen to the words I'm saying. I'll just talk you through it because it's going to take too long to write it, and then it's not really going to help you as much. So when I see this question about emits light, this is, as soon as I see emits colored light, that is excited electrons. So this is where you have to be able to say an electron absorbs energy, jumps to an excited state, then when it falls back to ground, it emits that energy in the form of light. That's what you need to be able to say. Okay. This question, state evidence from the bright line spectra. Did I skip one? Let me just check. State how the bright line spectra view through a spectrum used to identify. Oh, so they are intrinsic properties, right? They don't change based on the amount of substance. So if it's intrinsic, I can use it to identify, just like density is intrinsic, and we did that in the first unit, right? So in this is another intrinsic value. So you need to know that word intrinsic. Evidence from the bright line spectra that A is not present. Well, let me go to A, and I see here's element A, and here's the mixture. And notice this line is not in my mixture. That line must be there. A lot of these other lines are really close, right? This is the one that really stands out. So literally, the band at approximately 700 nanometers is missing. And I believe that's what I wrote in the answer key, right? This line is missing in the mixture. You could say not all of element A's bands are present in the mixture. or you could identify the 1 at approximately 700 nanometers. Explain why the spectrum produced by 1 gram is the same as 2 grams, because it's an intrinsic value. Intrinsic just means, by definition, independent of amount and independent of heat. In this particular case, the amount of energy does create the whole spectrum, but you notice that we're not talking about how much heat it took. We're just showing which one showed up. Okay, so that's a little bit ambiguous in this particular case. When it comes to density, it's for sure mass doesn't change it, neither does heat. Energy change it. Energy doesn't necessarily change it. At that energy, it will always be that. Does that make sense? So it's not like energy is a variable that determines whether or not it will have a green light or a yellow light. As I steadily increase the energy, I get the entire spectrum. So the energy doesn't really fall into negating that definition of intrinsic value here. I know it's a lot of words, but in both electrons and energy states, how light is produced. So this is the same thing. Ready? Electrons absorb energy. So as soon as you see spectral lines produced, emitted, light, anything like that, we're talking definition of excited electrons. So energy or electrons absorb energy, jump to a higher energy level, then they reduce, or then they emit that energy in the form of light. Okay, so as soon as I see that, that's what I'm thinking every time. Okay, here we got a Bohr model. It says state the atomic number and mass number of this element. So this is hidden in the reading somewhere. We know atomic number is just the number of protons. It says right here it contains 4 protons. Mass number, we know that the mass number is protons plus neutrons. We did that extensively at the top of all of our pages, right? So that's going to be, that's where I get the 9 from. Add protons and neutrons together. So 4 protons, look it up. 4 protons is Be. Be has an electron configuration of 2, 2. State the number of electrons in each energy level of this atom and ground state. Boom, 2, 2. 2 in the first, 2 in the second. Okay. Then it says using the Bohr model, describe the changes in electron energy and electron location when an atom changes from ground state to excited state. So this is the 3rd time in these 2 pages that the exact same answer comes up. Do you think that I'm trying to make sure you understand this answer? I'm going to go through it one more time. Ready? Electrons absorb energy and jump to the excited state. Then, as they fall back down to ground, they emit that energy in the form of light. Done. You need to be able to have that kind of memorized in a way that makes sense. And this is just numerical setup. I did the answer for you, and I did it more fast math. You can set it up how we did it in the, exactly how I did it in the practice pages. You just got to remember the percent has got to be divided by 100. So you could set it up this way, 0.9326 times 38.96. Oh, see, so this is why I didn't do it this way, because then it's tough to show you that you add them up. But this is how we did it, right? And I take this 0.01, and that's 0.0001 times 39.96 equals, and then I have 0.0673 times 40.96, and then add up the answers. This is how we did it in our notes. You'll see that I did it more mathematically by doing this with a plus sign, and then this with a plus sign, and then this with a plus sign, because that's a little bit more of an accurate way to just set it up. So that's why I did it that way, with plus signs in between. Some form of this way, as long as I could see what you were doing and that this has been changed to decimal form. If you've done that and multiplied it by the correct mass and added it all up, if you've done that in any way, you would get full credit. And I'd have some sort of leeway as a Regents grader to follow your setup. just so we're clear, when it shows show correct numerical setup, I cannot grade your answer right or wrong. I can only grade the setup because that's what it's asking for. So it's very specific. So you don't have to waste time answering this question. All you have to do is set it up whenever you see that. What we're going to find later on in these kind of problems is it's going to say explain in terms of, and that's going to handicap us. It's going to handcuff us. There could be 5 different ways to answer that question. And once it says explain in terms of, then you're stuck with that one way. Okay. So in a nutshell, there's me hopefully guiding you through these Regents questions and breaking them down. I hope it helps. So let me know if it did or didn't help, and I will change how I do it. All right.